Welcome to this week's Contrarian Coding news. While the mainstream narrative surrounding Erlang in August 2025 continues to center on its unparalleled strengths in building massively scalable, fault-tolerant distributed systems, often through the lens of the OTP framework, and increasingly via Elixir for web and general-purpose applications, a contrarian or under-the-radar viewpoint could focus on its underutilized potential as a supremely robust and highly concurrent local automation and complex scripting language. The prevailing focus often emphasizes Erlang's let it crash philosophy and its capabilities for global distribution, leading many to overlook its profound utility for tasks that don't necessarily require multiple physical nodes or extreme fault tolerance across an entire system. This alternative perspective posits that Erlang, with its lightweight processes, immutable data structures, and powerful pattern matching, is exceptionally well-suited for 1. Complex, concurrent local tooling. Instead of relying on Python or Ruby for intricate build systems, data processing pipelines, or system automation scripts, Erlang offers a superior foundation. Its actor model allows for natural concurrency in managing multiple files, network operations, or external process interactions locally, without the overhead or complexity of threads in other languages. This enables the creation of highly responsive and reliable command line tools and desktop utilities. 2. Declarative logic and rule engines on a single node. Erlang's functional purity and pattern matching excel at defining complex business rules, state machines, and data transformations in a highly declarative and readable manner. Rather than being confined to distributed system configuration, this strength could be leveraged more broadly for single-node applications requiring sophisticated logic, such as intelligent agents, data validation engines, or even advanced game AI, where the focus is on the clarity and correctness of the rules themselves rather than just their distributed execution. 3. Industrial strength single-process applications with internal robustness. While let it crash is a cornerstone, a contrarian view might argue for a more nuanced approach in specific single-process critical applications. Here, Erlang's process isolation could be used to build highly resilient internal components where some failures are handled with more sophisticated internal recovery mechanisms, e.g., sophisticated rollback, specific error contracts between processes, before resorting to the supervisor restarting the entire component. This isn't about abandoning supervision, but about leveraging Erlang's strengths for granular internal fault containment and self-healing within a single OS process, making it ideal for embedded controllers or highly critical batch processing, where even a brief crash and restart cycle is undesirable. 4. Microservices where the micro is literal and local. Rather than always deploying Erlang services as independent network entities, its lightweight processes could form a robust microkernel or component bus within a single application, allowing for incredibly efficient and isolated internal communication without network latency. This approach could be particularly beneficial for applications requiring high internal concurrency and resilience without the complexity of a full distributed deployment. In essence, this contrarian view encourages looking beyond Erlang's well-established role as the backbone of massive distributed systems and recognizing its profound capabilities for building highly concurrent, robust, and expressive single-system applications and tooling, where its unique architectural strengths can lead to unparalleled reliability and maintainability in often overlooked contexts. And that wraps up another edition of Contrarian Coding News, where the status quo is always up for debate.